Good afternoon, everyone. I'm Cassie with AABC, and I'd like to welcome you to today's Tab Talk webinar. I also want to thank our sponsor, Ameritech, for supporting this session. Just a few items to cover before we get started. Our presenter will be holding questions until the end of the presentation, but we encourage you to submit them at any time using the Q&A button at the bottom of your screen. If you happen to be experiencing any technical problems during the webinar, please use the chat function to inform the panelists so that our producer, Sim, can assist you. This presentation is being recorded and it will be available for viewing in 1 week. In terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you're a certified TBE or TBT, your CEUs for attending any webinar in this series will be automatically uploaded to your respective portal after the webinar. Today's webinar is Leakage and Deflection Testing of Air Handling Units. Please welcome today's speaker, Jeff Keene, TBE CXA Lead AP. Jeff is a distinguished professional in the HVAC and building commissioning industry, currently serving as Operations Manager at Palmetto Air and Water Balance, Texas. Jeff graduated from the University of Central Florida, where he laid the foundation for his expertise in the field. Without further ado, I'd like to hand it over to Jeff to kick us off.
Thank you. I appreciate it. Thank you everybody for joining in to this Tab Talk. Hopefully everybody can see my screen now. So again, as was mentioned, we're going to discuss leakage and deflection of air handling units. This is something that we started doing several years ago at the request of a unit manufacturer that we do work for. And it's been a valuable asset to us. It exposes us to potential clients as well as generates revenue for the company, of course, which is pretty much why everybody is in this business, to generate revenue. So we'll get into why we test, why we do unit leakage and deflection test. The primary reason, or the first reason, is typically because the specifications require it. So you'll have a manufacturer or a general contractor or a mechanical contractor notice that they have a specification that require on-site testing for unit leakage and deflection, and they've got to find somebody to do it. So they'll contact a firm like ours or yours to take care of that testing. Another reason is the unit was assembled on site. Most unit manufacturers will have an acceptable leakage rate that they have on their units and that they publish, and they'll indicate, what the leakage rate when they test it at the plant is, and they cannot assure that leakage rate if the unit is assembled on site. So that's when they'll contact us to say, hey, we need you to go after this unit's assembled and test the leakage to make sure that it's still within our standards. And then the last reason we typically will test is for diagnostic reasons. This is typically when an owner knows that the unit's leaking. They have water intrusion if it's on the roof, or they've got condensation around the discharge seams of the unit, which usually will end up with some type of microbial growth on the outside of the unit surrounding those seams. And they'll ask us to come in and test it to see exactly how bad the leakage is and what we can do about it. So as far as the specifications are concerned, this is just an example specification that is going to indicate what the pressure is going to be, what the allowable leakage is going to be, and what the allowable deflection is going to be. We'll get into all this a little bit in more detail later, but this is just an example of a typical specification that you would see for leakage and deflection. We literally just pulled this out of one of the jobs that we did. So I'm sure everybody has seen the units that get assembled on site. And this is typically the majority of the units that we do, or we're asked by the manufacturer or the distributor to check units that have been assembled on site. Sometimes the manufacturer will assemble them. Sometimes the manufacturer will have a representative, or the distributor will have a representative on site when it's being installed. But more than likely, it's just the mechanical contractor installing the unit and assembling the sections themselves when the pieces get there. As with every piece of equipment, I'm sure everybody here knows that there's detailed installation and operations manuals that are sent, and they're very detailed about how the unit should be assembled, what materials should be used to seal the seams, how the seams should be sealed. And strangely enough, they don't always read them, and they don't always follow those guidelines, and they'll just slap them together as quick as they can, and therefore generates the opportunity for us to go out there and test them. And then, of course, the final is, like I'd mentioned, for diagnostic. This is a project that we did for an owner that this was years and years ago. You can see we introduced smoke to this particular unit to see where it was leaking. This was multiple units on a project that ended up in litigation, and we got brought in to prove essentially that the units were leaking, and leaking substantially. So that's why we test. The three primary reasons why we test, and they're all good reasons. And again, it generates an opportunity for firms like ours to go in and help clients. I'm going to repeat myself on several things throughout this presentation, and I do on purpose, because I think it's vital that you understand the test and what you're getting into if you're going to do these types of tests. So understanding the test, we're going to start with the pressure requirements, understanding the pressure requirements, because the requirements on unit leakage are not always standard. At some point, hopefully they will be, but we see we see it all over the map. Of course, the pressure ratings are in the United States are typically going to be expressed in inches of water column, which is the standard that everybody here sees. If you're overseas or in Canada, you may see something differently, but here we always see it in inches of water column. And it typically is going to say something like this, that that you're going to pressurize a unit at 2.5 times the rated pressure. And again, we pulled this out of a spec as defined by the total static pressure of the unit, or 10 inches, whichever is smaller. But again, it's not always standard. This is just an example. We've seen leakage pressures demanded as low as 8 inches and as high as 12 inches. So the question when it comes to it is it reasonable? Is the pressure that they're asking for reasonable? As I mentioned, we ran into a test where they wanted on a fairly small unit 12 inches of static pressure, which everybody here I'm sure understands is a large amount of static. And the unit was only rated in this particular spec. It wasn't the 2.5 times the rated static pressure. It was just a flat. We want it tested at 12 inches of static, and the total static pressure of the unit was only like 3.5 or 4 inches. So we approached the design engineer and just wanted to make sure that, okay, is this truly what you want? Do you truly feel that a 12-inch test is reasonable? So it's not a bad idea to approach it that way. And of course, the specifications should say whether it's a positive test or a negative test. Do they want to test it positive or negative? They frequently will ask you to test it in a positive and a negative. So they'll want you to separate the sections, and they'll want to test the negative side of the unit under a negative pressure, and they'll want to test the positive side under a positive pressure. What we always recommend is, if that's what they want, especially when you're running 8, 10, 12 inches of static, that we always request that the manufacturer send us something saying that the interior wall is capable of withstanding that type of pressure. Because of course you've got to separate the chambers. They've got to seal between the mixing chamber and the discharge chamber of the unit. And that interior wall frequently is not a structural wall, and it's not capable of withstanding the pressures that you're going to exert on this. I can't stress this enough. We learned this the hard way when we separated that interior wall by about 6 inches before we even got to the static pressure. So from now on, our procedure is, if they want a positive and a negative test, we require the manufacturer to basically say that yes, that's going to be acceptable. And then finally, is the equipment that you have capable of achieving that pressure? If you do a lot of duct testing, you're typically testing to 6 inches. A lot of the fans are smaller fans and have no problem doing 6 inches of static, but not everybody has a fan that can get up to 12 inches of static. So you'll want to make sure that the equipment that you have is capable of achieving the static pressures that are required for the project. One of the questions, there's a Q&A at the end. I am curious, though, of the people that are attending this Tab Talk, of how many people here do this type of testing, and or one, how many people here do it, and how many people are thinking about doing this in the future? I'm assuming most of you are at least considering it, or you wouldn't be at this Tab Talk. So the next step is understanding the leakage. And it's a similar thing. It's going to be typically expressed as a percentage of the total CFM. In the spec that I presented earlier, I think said a maximum allowable leakage is 1.5% of the rated flow. Again, this isn't standard. This isn't something that is always 1.5%. We have seen it as low as 0.5%, half of 1%, all the way up to 2% of the total flow. So again, it's not always standard. I think once or twice we've seen it listed as a leakage class. That's not something that we typically see. Again, the one that we did see as a leakage class, this is an example of what they put in the specifications for the leakage class. again, we rarely see it as a leakage class. It's almost always a percentage of the total flow. That's what we've seen. And just like the pressure, is the CFM reasonable? Again, we just tested a unit. It was a 10,000 CFM unit. They wanted it at 0.5%, so we were only allowed to leak 50 CFM. We brought it up initially that this is an extremely small amount of CFM for such a large unit. And when I say large unit, 10,000 CFM is not a very large unit, but this was a very complicated unit. This unit was about 7 feet tall, 8 feet wide, and 30 feet long, because it had a lot of different components in it. It was for a medical facility, and for something that has that much area, 50 CFM is just not reasonable, in our opinion. Ultimately, we never were able to get to 50 CFM, so they finally did accept what we had. I think we got it down to 60 CFM or something like that, or they got it down to 60 CFM. So, and just like with the pressure, can the equipment that you have achieve that CFM? Is the fan that you've got capable of achieving the static and the CFM? And then finally, can your orifice tube accurately measure that CFM? So when you're approached with this type of test, we always recommend that you totally understand the test, and that you understand that your equipment can do what's required of the test. And then the last section is the deflection side of it. And it's all the same, pretty much a repeat of all the other ones. It's usually expressed as L over something. In the spec that I listed, it was L over 250. So the way L is defined typically is the height of the largest panel on the sides, width of the largest panel across the top, and the smaller of the width of the largest panel on the ends. So, of course, the first time I looked at this, I looked up, I'd never done it. I looked up L over 250 to even see what the definition, what that even meant. L is actually, defined as length, and you think, oh, it's a 10-foot unit. That's 120 inches over 250, but that's not the way they're typically going to do it. So, like the others, is the deflection reasonable? I will say in our experience, we typically don't have too much of a problem with deflection. Our deflection rates typically are either L over 200 or L over 250, or somewhere in between there. We see L over 220, 240. But it's usually somewhere in between L over 200 and between that and L over 250. We rarely have deflection fail, but we have seen it. So the deflection rate is typically very reasonable. And in the equipment that you have, is it able to accurately determine what the deflection, your deflection rate may actually be very small. You may have a deflection rate that's only, a little over 1/10 of an inch. So you need to make sure that however you're using your deflection rigs, that it's able to detect whatever the deflection may be. So after you understand the test, we feel that it's vital that you plan for the test. This planning, of course, should always include the contractor or the people that are going to be there with you for the test So you want to make sure that they understand what the expectations are for the test. We talked about the specs, we talked about understanding the test. It's if there's any ambiguity in there, we always recommend that ambiguity gets clarified. So everybody is on the same page. The manufacturer, the owner, the engineer, the mechanical contractor, that everybody is on the same page and expecting the exact same outcome for the test. There's which has happened to us in the past. There's nothing worse than you're pretty sure how everything's supposed to be done, and you do the test, you submit the test, and the engineer comes back and he thought something different than what you thought. So that's part of understanding the test. You want to make sure that everybody's on the same page, and that includes on the planning. You're going to want to make sure that the contractor understands that that they're responsible for sealing. We just like in test and balance, we're not going to install anything. We're not going to repair anything. It's a similar thing when we're doing leakage and deflection testing. We're not going in there and sealing things up. We're not partitioning off the interior of the unit. We're requesting that they do it. So we want to make sure that they understand what all is expected of them as far as sealing the unit. I will tell you that one of the common things that gets overlooked are any type of knockouts that may be there for electrical. The condensate is typically overlooked, especially on a lot of these units. You may have multiple coils and there may be multiple condensate openings. So again, it's just important to make sure that they understand that what needs to be sealed, and also at what level it needs to be sealed. The first time, well, I won't say the first time, but early on when we did this, we're like, okay, you guys need to seal up the unit. And we thought we were pretty clear. They knew that the test was going to be at 10 inches, and we got there and they've got everything sealed off with duct tape and plastic. As I'm sure most of you here can imagine, duct tape and plastic, it isn't quite going to be strong enough to hold a 10-inch test. So it's just good to be clear on how it needs to be sealed, so you're not running into issues when you get there to test. You want to make sure that they have power for your fan, or at least whether there's power there or not. A lot of times these units are on the roof, and there may not be a spider box there for you to plug your fan into. Typically when we're testing these fans or testing these units, it's early on in construction. They've just set the units. They don't have permanent power. They're running spider boxes everywhere. The particular test fan that we use for this is a single phase 220 fan. It's not just a standard 110 fan. We use that just because it's able to do everything that we need to do. Early on, we were using our standard 110 duct test fans, and we noticed that we were having to either run them in series or parallel. We'd have to run two fans in either series or parallel, either to achieve the static pressure or the overall leakage that was allowed. So we ended up buying a different fan, and that's why, again, I get back into understanding the equipment that you have is capable of doing the tests that you need. I keep reiterating that because we learned all these lessons the hard way. So we also we can provide, again, at an additional rate. We have generators that can run our fans if we need to. Again, learning the lesson the hard way. Our fan has a VFD on it, so we'll, make sure if your fan doesn't have a VFD that your compressor or your generator is capable of running your test fan. Because again, we've had experience where we try it, and yeah, amperage wise and everything, it should be a problem, but it trips the generator on startup of the fan. So again, you just want to make sure that you've got power for the fan, whether you're providing it or whether they provide it. You want to make sure that you dictate what tap needs to be installed and where the tap needs to be installed for your test fan. So again, if they're running a positive and a negative test, then typically we will ask them to put a tap in the blank plate that they're putting on the discharge of the unit, and we'll ask them to put a tap on the blank plate that they install on the return side of the unit. You want to make sure that you're clear about what size tap. That fan that we use has an 8-inch orifice tube, so we always tell them that we need 2 8-inch taps or 1 8-inch tap, and we try to as best as possible dictate where that tap needs to be, because that'll help you in the future. You want to make sure you understand how you're going to get your test fan to the test location. This can be quite challenging at times. We've had issues where we did one. The fan was on the roof of a 4-story building. There were no elevators. They didn't have a boom lift that could get it on top. There was no exterior, elevator for the high rise. So getting the fan to the test location sometimes can be quite tricky. So you want to make sure that you've got that covered, that you know how you're going to get your fan to the test location. And even once you get it to the test location, you want to make sure that you understand how far, again, some of these units are quite large, and the site might be restrictive, and it may be hard to get your test fan close to where they have the port, where they have the tap installed for you to hook your test fan to. We've ran this multiple times. For example, the unit is literally 14 feet tall. It's a top discharge unit. So the tap is on the top of that unit, and we couldn't get the fan within 10 feet of the unit. So you needed a 25-foot hose in order to hook up to the tap. So again, it's not just getting the fan to the unit, it's making sure that you can hook your fan up to the tap that's there. So you need to plan for that. So when you're doing your planning, you want to inspect the unit. You want to check the unit installation. Again, depending on, we typically try to find out who installed the unit, if it's the manufacturer that installed it, if a manufacturer rep was there to witness it, or if the mechanical contractor did it. The way we see it is it's very similar to startup, which I'm sure all of you can relate to. If the manufacturer does startup, you can usually rest assured that it's done fairly well. If the manufacturer has somebody there to witness startup, you can usually rest assured that it's somewhat done. But if you're relying on the mechanical contractor to do it, you might want to spend a little more time looking over the unit installation. You want to make sure that the contractor has completed all their requirements. They put the proper blank offs on, they put the proper taps in, that everything's sealed off, and make sure that the unit is ready for actual testing. We always, we'll spend literally, we'll contact everybody. We'll have a meeting, and it can be a phone meeting or a Zoom meeting. We don't have to go out to the site, but we'll have a meeting well before that we test the units. It's typically 2 to 3 weeks before we test the unit, and we try to clarify all this to make sure all the contractors and everybody's on the same page. And then when they say the site's ready for us to test the unit, we'll go and we'll check this before we ever unload any equipment, before we ever think about bringing anything on the site. Because as I mentioned before, sometimes it's quite cumbersome to get your equipment to the site. So you want to verify everything's ready before you actually get out there. As I keep saying, you want to make sure that the appropriate equipment is on site, that you have it on site. I keep reiterating this because, again, we've learned this the hard way. Not all the equipment is your standard tab equipment, especially when we get into deflection. I keep reiterating and making sure that you've got the right equipment, because it's the equipment that we use to test these units wasn't the typical leakage equipment that we had previously. I've talked again about power requirements, that especially if you're not running a 110 fan, if you have a 110 volt fan, it's typically not nearly as problematic. But if you've got a fan that's a 220, or especially if you're running a 3-phase fan, you want to make sure that you'll have the power there. As I mentioned before, you want to make sure that they know how you're going to get the fan there. You need to make sure you've got a hose long enough to reach the test tab. You want to make sure that the fan that you brought can achieve the pressures, achieve the CFM. Again, I can't stress that enough, because you don't want to get there, hook up your test fan, and your test fan can't achieve the CFM or the pressure that they're requiring. Of course, item on the left, standard duct test fan. That's a lot of you guys here probably already have something like this. Whether it can reach 10 and 12 inches, and the allowable leakage rate is another thing. Again, I keep reiterating this because it's not standard, and we've seen it all over the map. We've seen units that a 40,000 CFM unit that was at 1%, so 400 CFM at 12 inches of static. A standard duct fan is not going to get 10 inches of static and be capable of delivering 400 CFM. So you just want to make sure that the equipment that you use can do it. The deflection system that we use is this is a picture of what we actually use. It's just a machinist dial gauge with a magnetic stand. We had some stands built. Deflection can be done in multiple ways. We'll get into that just a little bit more here in just a second. But the deflection, like I said, this is the method that we use, is a dial indicator and machinist stand on stands that we had built. As far as the leakage, really no different than any duct leakage test, except you're doing a unit. So the rates may be a little bit different, but the leakage is no different than you would a standard duct. You're going to make sure that you ramp the fan up, to achieve the design specified leakage pressure. You're going to obtain whatever the leakage rate is, record that. We typically see the leaks at seams. That's the most common place to find the leaks. It is very common to do what we call chasing CFM, to chase small amounts of CFM. The first time you test, you may, the leakage rate the allowable leakage may be 100 CFM. And the first time you test, you may not even be able to get to the static pressure. It's leaking so bad, which is common. Or you may achieve static pressure, but you're leaking 400 CFM instead of 100. That they'll postpone the test. They'll, seal the unit accordingly, and you'll come back and test. And so it's not uncommon to go from, 400 CFM down to 150 CFM. So you gained a lot of ground. You went 250 CFM. You were able to seal that much off, but that last 50 CFM can be quite challenging from time to time. That's where choosing the best orifice tube is very important. You want to make sure that the orifice tube that you're using is that allowable leakage is somewhere in the middle. You preferably you don't want to use an orifice tube that the leakage rate is on the bottom end or the top end of that tube, because if it is, or if it's even, we've seen it where it's off of the chart from the tube, and you're using the calculation, you're just leaving yourself open to being questioned, whether it be by the mechanical contractor, by the engineer, by the owner's rep. So we always recommend using the orifice tube that the allowable leakage rate is right there in the middle of the leakage rate readings of that particular tube. As you saw in that one video or that one picture, smoke can be helpful, but not always. So what we see frequently is when we introduce smoke, it's leaking from so many different seams that the smoke just dissipates, and you can't really pinpoint where it's coming from. Smoke is very useful when there's one specific point that's leaking, like in that picture that I showed you, because then it's just billowing out of that one spot, and it's easy to identify. But if you're introducing smoke with a smoke generator, it's not always helpful. When we're chasing that CFM, typically what we'll do is, instead of introducing smoke to the test fan with a smoke generator, we'll use a handheld smoke puffer. We buy these little electronic smoke puffers that they're actually designed to determine, which way the wind's blowing when you're hunting, and we find them very useful. We put the unit in a slight negative, and then we'll run along the seams with that smoke puffer, and then you'll see as soon as there's a leak, it'll just sweep into the unit wherever it's leaking. So when you're chasing that small amount of CFM, it's helpful to use a puffer and do it negative. I will say that 90% of the units that we test, and that's probably being conservative, fail the first time we test them. So when we send out proposals for this, we always are very specific on the proposals that we send out, clarifying who's responsible for what, and that retest will be at an additional fee, because it rarely, if it fails, can they get it to pass that same day. It almost always is going to require you to do a second visit. I bet less than 2% of the time have we been able to get the unit to pass the same day when we fail it. And this is one of the reasons why this is something that we pursue, is because you're going to make money off of it, because if it fails, you just continue to charge. I mean, we've retested units up to 4 and 5 times. You can't, you just need to make sure that they understand if the unit fails, that it'll be additional services. If you don't do that, it'll eat you alive, because we rarely see them pass leakage the first time. Deflection's a whole nother situation. Again, this isn't the rigs that we use now, but this is an example. Again, we've tried a bunch of different things. This is where the dial indicators are clamped onto a rail that's has just been put on the side of the unit. We've tried lasers, putting a laser that runs across the side of the unit. But what we've personally have found that works the best is just using dial indicators, setting the dial indicators up similar to the way you see it here, but we just have it on that magnetic stand, and we zero it out, and it clearly indicates what the deflection is after the unit's achieved the design or the specified static pressure. Again, that's not something that we see fail very often. We do see it fail from time to time. Where we typically see it fail, just so you guys know, is on the end panels. So where your discharge is, or when your discharge or your return are on the ends of the units, that's where it usually is going to fail, if it's going to fail deflection. We try to always clarify where they want these deflection readings taken, and how many are taken. That's another thing that we specify in our proposals is, we'll up to a certain amount of deflection points. And again, it's something that you want to get clarified before you get to the site, because you don't want to bring 4 dial indicators and then find out that they want 12 deflection points taken, because then you're going to be setting the test up 3 different times to get your 12 different readings. So again, that goes back in making sure that you've got the equipment and the appropriate equipment to do the appropriate test. Typically, when we do this, it's witnessed by somebody else, either a commissioning agent, a tab firm may be witnessing it. It could be the owners, the engineers, and we will typically let them choose where they want the deflection points, because again, we want to be independent. We want to make sure everybody understands that we're not here to fail the test or pass the test. We're here just to do the test, to grade it and see what's out there. So if you let them pick the deflection points, you can't have somebody come back and say, well, you only tested the deflection points that you knew wouldn't pass. So we typically ask them to provide the points where they want them. So the deflections, again, we set the braces and the micrometers up wherever they need to be. It's pretty straightforward. We zero them out prior to the test. And then the one thing that I'll say is you need to make sure you protect your dial indicators, because we've gone through quite a few where technicians weren't quite as delicate with them as they should have been. And as I mentioned a second ago, you need to determine where and how many points are going to be tested. And, again, it's rare for them to fail on deflection. So that will wrap up. I think I'm right on time. So that wraps up the presentation, the tab talk. Of course, we'll open it up to any questions and comments, and I'd be happy to hear from you guys.
All right, thank you so much, Jeff. That was great. We have a couple questions coming in already. This one says, at what point after assembly of the air handling unit would you recommend testing take place? Would this be immediately after, or do you have a recommendation for that?
Yeah, we typically, again, we leave it up to the contractor because just like with anything else, the contractor's trying to meet a schedule. We always recommend as soon as we possibly can. So yes, as soon as they get it installed and ready, that's when we recommend testing, because again, they typically fail. And we're on a project right now where we've been testing the same unit for a month and a half. But we haven't been able to get a unit to pass for a month and a half. So yes, we recommend as early as you possibly can.
All right, this next question says, when testing for leakage, where can we find the deflection number?
It should be in the specifications. If it's not, like I'd mentioned earlier, if there isn't a specification that indicates where that deflection number is, that L over 250 or L over 200 or whatever it is, we always just request it from somebody, whether it be the manufacturer. Again, if you look at submittal on the manufacturer submittal, it's typically, and it may not be in the submittal, but in somewhere in the manufacturer's documents, they're going to have what the deflection rate is and what the leakage rate is on any given unit. So we're just trying to make sure that it's under what the manufacturer's recommendation is. So if it's not in the specifications, then I would go to the manufacturer or the engineer that's requesting the deflection and clarify it with them.
All right, this next one says, I noticed you had a manual damper on the blower TAP picture. Is that for dialing in the SP?
So yes, I will say the fan that we use now has a VFD on it. We don't use a lot of duct test fans. Just have like you said, they'll have a slide door or something on the suction side of the fan, so you can dial in the static pressure. The test fan that we use, and the test fan I would highly recommend, if you guys can afford it, is to get a test fan with a drive on it. Because one, if you're using a generator, you can start it off at 30 hertz. It's easy on the generator, and you can dial in that static a lot easier. So, but yes, that is what that was for. But the fan that we use currently has a drive on it.
All right, next up, this says, when testing units with HEPA filters, so hospital units, do you leave the HEPAs in place?
We have, yes. It doesn't affect them. Typically, when we're testing, there'll be no filters in there. We have tested them with filters in them, but we typically, but when we're testing, the filters are not installed. I would say 95% of the time there's no filters installed, but we have tested it with filters installed previously. I would recommend, though, if it has help, I would recommend they take them out, because you don't want to get blamed for causing a problem with HEPA filters. So, but it won't damage the filters. You may get them a little bit dirty, but typically they're not in there at all.
All right, we've got a few more minutes for questions, so keep sending those in. This next one is who typically contracts the leakage and deflection test?
So in our case, our two main clients are the unit manufacturer. So that's our primary, is the unit manufacturer. We work for we've done it for Train and Carrier and Linux, or the distributor. So here in Texas, one of the big ones is Texas Air Systems. We do a lot of work for them. So for us, it's typically either the manufacturer or the distributor, because again, they're just trying to meet their guidelines and prove to the client. We have done this for owners, and we've also done it for mechanical contractors, but for the most part, it's the manufacturer or the distributor.
All right, this next one says, is the deflection test always required, or is that a somewhat new test?
It is not always required. I would say it's if I had to put a number to it, I would say 75% of the time we do deflection, and 25% of the time it's only leakage. Again, the deflection is more dependent on whether the owner and the engineer want it or not. But we don't, no, it's not always required. And as far as it being new, no, the very first one that we ever did required deflection. So, you know, that we've been doing the deflection part of it very early on.
All right, keep those questions coming. This is a great discussion. Next up, it says, what are the general types of projects and units that you see this type of testing used for? Healthcare seems to be the big example discussed today. Also, if it is pertinent, what are some areas that you never see leakage and/or deflection testing done?
So healthcare is the biggest proponent. That this is healthcare and college are the two main ones that we've seen. We actually surprisingly, we did 53.5-ton rooftop units for an airport, which I thought was interesting. So, but yes, healthcare is the primary client that we see it in, and then the higher education, the colleges. We've done several for colleges. I personally have never seen this done on any schools on K through 12. We've never done it for any K through 12, and I've never done it for any type of private lease spaces like high rises or anything like that. It's almost always been colleges or healthcare.
All right, next up, when do you usually introduce smoke to the test?
So from our experience, the only time we typically will introduce smoke is if the leakage is excessive. So let's say the allowable leakage is 100 CFM and we're leaking 700 or 800 CFM. That's typically when we'll introduce smoke. But honestly, we typically won't introduce smoke. It's probably less than 20% of the time that we introduce smoke. The little smoke puffer that I talked about, we use much more frequently. But the smoke generator being introduced, it's a small percentage of the time, but it's typically if we've got an excessive amount of leakage.
All right, we've got another question. When conducting the leakage and deflection test, should all upstream and downstream ductwork be completed?
It doesn't matter. No, typically when we do it, there's not even any ductwork there. Like I said, they've set the units. I won't say typically, frequently. There's no ductwork. They've set the units. I mean, the one of the earlier questions is, when do you want to get in there and do it? And I mentioned as early as we possibly can. So yeah, we've done this when buildings aren't even dried in. They set the units and the buildings aren't dried in. So of the duct, since we're testing the unit and not the ductwork, it's irrelevant to us whether it's installed or not. But most of the time, it's not even there for our purposes.
All right, and we will call this one our last question. Will the AHU manufacturer ever give testing procedures for the field?
Yes, yes, and like I said, so from our standpoint, if there are no specifications, if it wasn't, if we're testing because the unit was installed by on site and it wasn't a specified test, the unit manufacturer, that they're the ones that are providing the the standards, at what rate and what pressures and what deflection. So yeah, the unit manufacturer will have that data. Typically, what we see is we're doing it to the unit manufacturer's standards, unless the specifications are different than that, at which case it may be. So we've seen where the specifications are less stringent than the unit manufacturer's conditions. So they test to the specification, which is a less, but yeah, the unit manufacturer can. And Casey, I don't know, did have people put, do we have any idea how many people here actually do the testing?
We had a couple of people react. We have not had any specific responses about that in the Q&A, but it definitely looked like people were sending in their thumbs up to that.
Great, yeah. We found it to be very, like I said, it's lucrative, and it opens up a lot of doors. So we definitely have found it to be beneficial for our firm.
All right, well,
So
that is
again,
a, oh, go ahead, Jeff.
nope. I was going to say, I want to thank everybody that attended, and if you've got any questions, feel free to email me or call me, and be happy to speak with any of you.
All right, thank you so much. That's a wrap for today's webinar. Thank you, Jeff, for an excellent presentation and discussion, and thank you also to Ameritech for sponsoring. Last but not least, thank you to everyone who joined us today. I want to remind you before we wrap up that we've opened registration for CX Energy 2025, which will take place in Charlotte, North Carolina from April 28th to May 1st, 2025. So we hope you can join us for that. Thank you so much for your valuable time. This is our last Tab Talk for the year. So happy holidays, and we will see you next year.